All right, welcome back. So in the last example, we were really looking at that y-intercept. And if that y-intercept changed, we knew it was a translation. But now what we're going to do is we are going to be looking at the slope. And the slope is going to tell us. So changing the slope of a line will change the steepness of the line. It will either get more steep or less steep. And this is actually called a rotation. So a rotation has to do with the slope of a line. So a rotation, you look at the slope. Okay, so that's really what we're going to be doing. So here, let's go ahead and look at all three of these examples. So we start with f of x equals x, and remember that is the parent function. And that's really what we're going to start at, which is right here. This is f of x, right here, okay? And then we're going to look at, and notice what's the slope here. The slope is equal to 1, right? Okay, now let's look at g of x. So g of x is right here. And what's the slope of g of x? Well, the slope of g of x is 4. So look at 4 is more than 1, right? So what that means is when the slope is more, it's bigger, it's going to become more steep. So this should become more steep. Now let's go ahead and graph it and see. So the y-intercept is 0, and then you go up 4 over 1, and then you have our g of x right here. And if you look at, and you started our parent function, right? When you get to our g of x, it rotates, and yes, it becomes more steep, right? And I always try to think about, okay, if I was like climbing up a hill, like this would be hard, but man, if it went like this, ooh, this would be super hard. So that always makes me like know that it's, helps me with more steep. So this is a certain steepness. This is the parent function, right? F of x. But then when that slope is more, then it becomes more steep. So we're really just looking at those slopes, right? Okay, now let's look at this next one, h of x, which is 1/2. Now what's the slope here? Well, the slope here is m equals 1/2. Well, if we compare that to the parent function, right? 1/2 is less than 1. So this one is actually going to be, it should be less steep. So whenever you have a slope and then the slope gets smaller, it's going to be less steep. And let's see if that, okay, so we have this right here. So the y-intercept is 0, and then the slope is up 1 over 2, which is this h of x right here, right? And so here's our function. And if you started that parent function and then you went here, yes, that totally gets less steep. Do you see that rotation? We started our parent function and then it rotates, and yes, the line is less steep. Okay? So basically, whenever you're looking at these, when you look and you see that that slope changes, you know that you're dealing with a rotation. So let's go ahead and look at a few examples. So for this first problem, what do you see? Graph f of x equals x, okay, that's our parent function, and g of x equals 1/3 x, and then describe the transformation of the graph from f of x to the graph of g of x. Okay, well, what's the slope of this? 1, and what's the slope of this? 1/3. So if the slope is 1, and then we have the slope of 1/3, this is less than this, so it should be getting less steep, right? Let's go ahead and graph it and see. And only the slopes are changing, so we know it's a rotation. So the parent function, the y-intercept is 0. The slope is up 1 over 1, right? So we can go ahead and graph that here. Okay, and that's my parent function, f of x equals x. And then my g of x is the y-intercept is 0, except for this one, my slope is up 1 over 3. 1, 2, 3, so right here. And the opposite, down 1 over 3, 1, 2, 3, this way. Okay, and my y-intercept is obviously there. And then I just go ahead and graph that. This is my g of x equals 1/3 x. And if we started here, you can see that it's rotating and it's getting less steep. So what we can say is that f of x is rotated and less steep. Yep. Oh, wait. To become g of x. All right? Perfect. So there's our answer right there. Okay, let's look at this next example, and I want you to go ahead and try this one on your own. So go ahead and pause your device, work it out. When you get done, press play, and we'll talk about it. Okay, let's see how you did. So we have to graph this parent function, right? And g of x. So f of x and g of x, and then describe the transformation of the graph from f of x to the graph of g of x. Okay, so the parent function is here. Remember, what is changing? The slope here is 1, right? And the slope here is 6. So whenever the slope is changing, we know that we're dealing with a rotation. And this number is smaller and this one's bigger, so when the number's getting bigger, it should mean that it's getting more steep. So let's go ahead and graph it and see. So our parent function, the y-intercept is 0, and then the slope is up 1/1. So you should have something like this, and this is our f of x equals x. And then let's graph g of x. The y-intercept is 0, and then we have the slope is up. Ooh, this graph is not big enough. Okay, so anyways, we'll make a 6. We'll make that be a 6. Okay, so up 6/1 right there. Problem solved. And g of x equals 6x. And you can totally see this is a rotation. We're starting here, it's rotating, and it's getting more steep. So f of x is rotated and more steep to become g of x. All right, if you got that right, awesome job. If not, go ahead and fix your problem so it looks exactly like mine. All right, we'll see you for the next example in a little bit.